So the main thing here is you want to move, let that load up here, smaller to the larger.
Mm-hmm.
This is sometimes unclear, but the smaller is the one that's more negative. So this is minus 5.7 R. So you're going to add 5.7 R to both sides. Is that okay?
Yeah, it's
So
because I started the equation and I started it by doing or by subtracting 9 from both sides.
you can do that as well. We can do that in this step here as well. That's fine. We've got to move it to the right. The point is you don't always move the variable left, although you just happen to in this problem. So it's 7.5 R equals negative 15. What do you do from here?
So then we divide by 7.5
Very
on
good.
both sides.
So R equals negative 2.
Yeah.
All right.
So now we could do 5 if you want.
Yep. Just keep going here. All right. So it says to simplify, and what they really mean is no negative exponents.
Uh-huh.
So in this case, we might want to do a small rewrite here. I'm going to rewrite this as 1/2 times k to the minus 4 power. Is that okay with you?
Yeah.
Clear why I did that? Now
Huh?
this k to the minus 4th is really 1 over k to the 4th.
Yeah.
All right. So now you multiply the tops and you multiply the bottoms. And this is your answer, I guess we'll say. So basically you're just undoing the negative exponents.
Yeah. Okay.
Like I said, if you want a similar one, just let me know. 6 kind of is similar. You really want to look at this as 3 things. It's 10 R to the minus 3 and t to the 4th. And it's this middle one we're gonna focus on here. So that gets rewritten as 1 over R cubed. You can think of 10 as 10 over 1,
Mhm.
and t to the 4th is t to the 4th over 1. Okay, so you end up multiplying the tops, 10t to the 4th, multiplying the bottoms, R to the power of 3.
Yeah.
All right, is 8 also on the list? I'm sorry, it's in the 7. I guess we're gonna do 7 before we do
Yeah.
8.
That's pretty. You're kind of similar. I don't know.
So
Mm,
the rule that there's some rules here, and I'm not really talking about them, but the main one here is that if you have a negative exponent,
okay.
it goes to the bottom. Okay.
Yeah.
But similarly, if it's a negative exponent on the bottom, it goes to the top.
So it would be just s to the negative, or just s to 3 on the top.
Yes. And on the bottom,
Everything else.
yeah, everything else, positive exponents though. Order doesn't really matter, but some people prefer alphabetical order.
Yeah. So then
That's it. And
that's
that's it
it.
for
Yeah.
yeah, there's nothing more to do. Sometimes like, well, am I done? Do I do everything? Yeah, it's sometimes hard to know. All right, so I was asking about 8 because this is a different class altogether. So write each question so that it is not biased. Is this actually something you have to do? Is that true?
Yeah, it's
Okay.
really weird, but it's about I don't know, it's like this lesson about like graphs and how they can look biased. I don't know why they have it.
Well, it's something you see in political science. So you can write, they call these loaded questions or leading questions. You don't want to write, you don't want to collect data with these biased questions.
Uh-huh.
So the words you want to, like, I don't know how you guys are doing this, but like you don't want to use words like shouldn't or isn't and best, better.
Yeah.
Those are the words that you want to eliminate. You really don't want to give a preference. So instead of talking about, you would just say, you would ask someone, do
Does
you, go
do
ahead.
you think, yeah.
I'm pretty simple. Do you prefer milk or juice? There's actually some bias in which one comes first, believe it or not.
Oh, okay.
What is the best class? C is kind of an interesting one. When is the best time to exercise?
Yeah.
Are you, do you like to work out?
Yeah.
You more of a morning or evening workout person?
So I'd say evening.
Yeah. Some people, if you go to any gym that opens up at any time, there's people right there at the opening. There's some people, and then there's people that want to be in there late at night. So it's all personal preference.
Yeah. Okay.
All right. Any questions on that? Because it looks like 9 and 10 get way more difficult.
I think I'm good. Thank you.
Okay. Let's look
Um,
at 9 here. So 9, when we look back at the 5, 6, 7, they're
Yeah.
not too bad. This one's got a ton going on here, so we're gonna have to piece this together. So it's like saying take this stuff on the outside, multiply it in, which we will do. I'm going to recommend though that we first kind of look at each of these as separate problems, like this problem, this one, and then this one.
Yeah.
So the it's just like the one we did on 7. So the negative switch position. So this r to the -5 goes to the bottom, z to the -7 goes to the top.
So like,
P z to the 7th, s to the 4th over r to the 5th.
P Z to the 7th, this is the 4th. And then you have, yeah, okay. And then for 7p or 7 over p to the second s to the first.
Good. Plus 5z cubed.
Yeah.
Now we can actually multiply in and have a chance here. So how do you want us to go about this? I would recommend doing it like one piece at a time.
Yeah, just kind
Um,
of distributing and
Yeah. Now, like, are you comfortable simplifying as you go, or do you want us to like multiply the top and the bottom and then simplify? What would be best for you?
I usually simplify at the end.
Okay. So this is well, we should do it in the right order. We should really do this in alphabetical order. So it's P s to the 5th, or I'm sorry, P r s to the 5th. Let me redo that. Z to the 7th over r to the 5th z squared.
Yeah.
Minus 7rs p squared s to the 1 z squared plus 5rs z cubed over z squared.
So, okay, yeah. I have it. Looking at it wrong.
It's really complex. I mean, this is by far the hardest problem we've seen so far. It's a good sort of question to put on a standardized test.
Z2 plus 5RS Z to the third Z to the second.
Yep. And now you got to simplify. So if anything is the same on the top and the bottom, you have to work that. So
Well, for the
like
first
R,
term, R,
yeah, where does the R go and what is its power?
I mean, you can only take away like one R from the
Right,
top.
right. So it's
And
R
then
to the
on the bottom.
fourth
Yeah.
on the, okay. And then you got to handle the Z's.
Yeah. And then for the next term.
Yeah, what's going on here? Anything
So
cancel?
we can take away that S.
That's right. One S on the top and one S on the bottom. So they go away.
Yeah. And then no R. So then just the next one.
Last one, Z's cancel.
Yeah. Or you can take away two.
Two from the bottom. Yeah. Good.
So Z to the one. And just one on the bottom.
Yeah. Or nothing. I mean, you can put a one there, or just not put anything.
Oh yeah, okay. And is that our answer?
That's it.
Or
Yeah.
yeah.
It's kind of hard to know. Are we done? Did we do everything? Yeah. It's a lot here. So 10 is actually easier than 9 in some ways, I think. But any questions before we move on to 10?
Yeah, I think I'm good.
All right.
Yeah.
Okay. There's a couple ways to do these powers. One is to distribute the powers,
Mm-hmm.
but you have to write it so that everything has a power. And that's what I think a lot of students don't do, is they don't realize, like, I actually need to write out what I'm multiplying by. It's more impactful in here with the negatives, but that's option one. The other option is to actually write it out like 2ab squared times 2ab squared. You can do this because it's two terms, so it's power of two. It wouldn't work as well if it were, say, power of 8. Then obviously it would be a lot of writing. So let's distribute. This is 2 squared, a squared, b to the 4th. Is that okay?
Yeah.
Now this other one, this negative, it's always awkward. Think of it as -2 to the power of 1 in parentheses b squared squared. So you're going to give that 2 to both of these. So it's really -2 squared b to the 4th.
-2 squared.
Yeah, like treat it like it's in parentheses.
My bad. All right. And then b to the 4th.
Yeah. Now, what is this parentheses -2 squared? What does that become?
+4.
Yes. So we've got 4a squared b to the 4th, +4b to the 4th. You combine like terms.
Yeah. So then you'd have b,
Yeah, you
So
combine the
6
B's and the number. Go
and
ahead.
then the 4s.
Yep.
So 16 B to the 8th. I mean A to the 2nd and B to the 8th.
Good. Yeah, really good.
All right.
Okay, number 11, we'll do next.
Yeah.
All right, let's take a look here. Handicap ramps. Building codes require that handicap ramps use no more than 1 foot for every 12 feet of horizontal distance. What is the maximum allowable slope of a handicap ramp? So, I mean, it'd be helpful to draw one just to kind of give your, some perspective here. Let's say it's going up.
1 foot
The
for every. Okay.
So
Yeah.
it's the rise. The rise is 12 and the run. I'm sorry, the rise is 1 and the run is 12.
So it would be maximum slope, rise over run.
Yes. So 1 over 12.
What is the maximum allowable slope? And that's the slope.
That's the slope. That's it.
Okay.
Sorry, it's not more complicated, but it's important. If you watch them build sidewalks, like they don't build runways. If they do, if they get too steep, they have to like notch them out or put like little things on the ground so that people don't, people on bicycles or.
Matthew,
Yes.
hi, sorry, this is David's mom. I wanted to mention, David has something at Saw Point today at 6. So if you guys are okay with ending just 5 minutes before, so instead of just at 5:45, is that okay?
Sure. Yeah. Whatever you guys
Thank
want.
you so much. I appreciate it. Yeah.
Yep.
All right.
The idea is you don't want it to be too steep. Have you seen on like road signs when you're traveling that say like 6% grade or steep slope ahead
Yeah.
or something? The idea is you got to be more careful because you can pick up speed really quickly
Oh,
when
okay.
you're doing that. All right, so 12 look like the next one here.
Yeah. Is it clear?
Yeah, I'm just making sure. Keep my head, I keep hoping you'll say, no, I already did 12. Skip it.
Yeah, you did.
All right. M is hiking a total distance of 620 yards. He has already hiked 272.8 yards. What percentage of the total has M already completed? Percentages is part divided by whole. What is the part? What is the part and what is the whole in this problem?
So the part is 272.8 yards and
Good.
the whole is 620 yards.
Good. So part A is this right here. That's part A. Part B looks like where we actually have to solve it. So we actually have to put those numbers in. 272.8 divided by 620.
Oh, okay.
Yes, are you allowed to use a calculator?
No, not really.
This one's gonna be pretty tough without that. Like really hard. So let's pretend like you have a calculator, or
Yeah.
maybe they want you to estimate. That's what I'm not sure of, like what is it? I mean, this does work out. I mean, I can show you how to do this out longhand. You put the 620 outside the house and the 272.8 inside the house.
Yes.
And so what you find is that it goes in 4 times. Okay, and that might take some effort here. But that's 2,480. I mean, are you doing this? Just help me out here. Like, are you actually doing this longhand?
Yeah.
Wow, wow, that's painful. Okay. You got to borrow from the 7, 4. Okay, and then you end up bringing a 0 down, and then it ends up being
44.
yeah.
Yeah.
I don't know why part C is asking for the reasonability of your answer, since it's
Yeah,
correct. I don't know. Check. Yeah.
The reasonability of your solution.
I think that it would be like if you were estimating, you would want to know, like, is it reasonable or not?
Yeah.
Yeah, sometimes
But
maybe
that's to estimate.
doesn't say it estimate, so yeah, I'm not sure. I might go back to my teacher and ask him what they meant by that.
Yeah, I'll ask him.
Okay.
So we can go to 13.
All right, sounds good. Gabby has $250 in donations, and she received pledges of $40 for every mile she walks in a charity walkathon. She wants to have a total donation of at least $500. Write an inequality to represent this situation. Okay. So there's what she already has, which is 250. Like she
Yeah.
must have, like she has that in an envelope or something. But then she's going to get $40 for every mile that she walks. And those are added together. All right. Now this word at least, does it go with which of the following symbols? If you know, if you don't know, I'll just tell you, but you want to take a,
I know it's C or D.
okay. So it is C. This is at least. And this is at most, or up
Okay.
to. So that's where maybe some note cards or some review could help.
Yeah.
With that, and at least $500.
$250 plus 40. Yeah, okay.
So a better question would be to find out, how many miles does she need to walk to
Yeah.
meet her goal? But that is it for 13. So
All right.
we will move on here to 14.
Yeah.
A storage box in the shape of a cube is filled halfway with packing material. So what do you know about a cube?
It's got 6 sides.
It's true. 6 faces. Yep.
And to calculate its surface area, just to calculate the whole.
Let me be more specific here. What do you know about each side in a cube?
So width and the length.
So in a cube, it's assumed that all the sides are the same length.
Yeah.
Okay. Now this one is filled halfway up with packing material. Okay. So it's all filled up with packing material halfway. So when they give you this number, is that the volume of the cube?
That's half of the volume in the
Half
cube.
of the volume. Yeah, half the volume. So if we double that number, that's going to give you the volume.
Okay. 5, 3, 2, 4. 2. Okay. So that's A.
That's part A. To find the side length of one cube, we have to remember what I was talking about with the side lengths. It's it's side times side times side or side cubed. That equals 1,648. 10,648. Now, to solve for S, you have to take a cube root of both sides. And you're not allowed to use a calculator, which I don't understand because this one doesn't work out nicely. So you're gonna have to use reducing roots here to do that. Let me just double check my calculations. So now I don't feel like I did the previous one correctly.
Let me,
Okay, I did not. It's
I thought you did. Wait. I thought you did. Or the for A.
no, I did. Okay, so this does work out nicely. I'm sorry. So you have to take the cube root of both sides.
Mhm.
You start with 2, and then 5, 3, 2, 4, and you try 2 again.
Oh, yeah, the prime factorization.
Yes. So that's
4.
2662. One, 1331.
662.
Now, that's not right. Oh, we need a triplet. Okay, yeah, that does work. All right. Now, this one is not a multiple of, not divisible by 3 because the sum of the digits doesn't add up to 3. 5 is out.
Yeah,
Now 7 does not work. I think it's 11 is the next one that goes in.
might be.
So the way you do 11 is you do something with alternating digits, but I don't know if you're going to do this very often, so let's not focus too much on that. And wouldn't you know it, you get a pair of 2s and or a triplet of 2s and a triplet of 11s. So the S is 2 times 11 or 22. And then we need units.
Oh, okay.
22 inches.
Yeah. So
That's the side length. 22 times 22 times 22 gets you back to the full volume.
yeah. 2 inches. Then there's no C. Yeah, okay.
No,
That's how you would undo I guess a square root kind of.
cube root. Yeah, cube root, you look for triplets. Square root, you look for just pairs.
All right.
$15.
Yeah.
Okay. Vicky's grade on her history report was 48 out of 60. Annie's grade on her history report was 47 out of 60. How much greater was Vicky's percent grade than Annie's percent grade?
47 out of 60. So we need to find what the percent is.
You do, but there's the shortcut here is to first subtract.
Uh-huh.
So it's 1 out of 60 and do that as a. So that's 60 on the outside, 1 on the inside. You got to do this awful long division.
Yeah. Oops. 400.
So you'll see that it does repeat here.
So it's a repetend.
Say that again.
It's a repetend.
Yes. I got my decimal in the wrong place. It's 0.016. So 0.016 repeating, or 1.7% ish, 1.6 repeating percent. I don't know how your teacher wants that.
No, yeah, my teacher just. What's with the 1.7?
So a rounded answer. I mean,
Oh,
this is not correct. Like you would never put this if
Yeah.
you went to a business meeting and you did this, they would not have any idea what you're talking about.
Yeah,
They also wouldn't care between 0.6 and 0.7.
yeah, okay.
All right, that's it. Like if you were to find 48 out of 60 and then 47 out of 60, you would then have to subtract them and you would end up getting the same thing. We saved a little bit of time there by subtracting first. All right, next one here. The data represents the number of clocks in 9 households. What measures central tendency best describes the data?
It represents the number of
1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I would write the data in order, and to do that, I would you write the number and then well, there's a bunch of them, but you kind of cross them out each time. There's 1, 2, 3, 4. So there's 4 5s. Then find the next one. It's 7. Cross out. Okay, there's 2 7s. And then an 8. And then a 10 and a 13.
Yeah,
So there's 3 measures of central tendency: mean,
median and mode.
median, and mode. Yeah. And I mean, this is a really weird situation. I mean, I don't have any clocks in my household.
Yeah,
Like, I don't know, maybe this is a big, back in the whatever. I guess they want the mode here because there is kind of a big mode. I don't really it's kind of situation specific, but I think that's probably the direction they're leaning. The difference between the mean and the median depends on whether there's outliers or not, and there are no outliers. So I guess I would suggest going with the mode on this one.
Mhm. All right. Yeah,
All right, so got one more question on this page. You may have to send over some more problems.
oh yeah.
Do you have 30 problems each day for homework?
Yeah, so we have 30 problems, but you only really do like the last, like you can do 20 and you'll get like full and you'll get the credit you need.
Oh, nice.
Like 30 is just for if you really need it.
All right, in 1997, the enrollment in a preschool was approximately 500 students. After that, enrollment increased by 20 students per year. Write an equation to model the students' enrollment y in terms of x. All right, so these are it's fixed plus variable, or the like startup.
Fixed plus variable.
Yeah, so like fixed is like what you're starting at. What are
Yeah.
you starting at in this problem? How many students?
500.
Good. And then the variable are the number of students that are either growing or decreasing. So in this case, 20x.
X, yeah.
So that's part A.
The number of years.
So that doesn't matter because 1997 is year 1 or year 0. That part will play a role in part B.
Yeah.
So in 2005, how many years later is 2005 from 1997?
8.
8 years later. So for part B, that's the number that's going to go in for X. You would not put 2005 in for X. It would just be unreasonable to grow that fast that soon.
Hmm. 8. So then we just add the product to 500. Yeah.
Yeah, you're gonna have 20 times 8 and add it to 500.
60. So 660 students.
Yes.
Okay. And that's it for B. Yeah.
Yep, that's all you need for B.
18.
All right. So 19, it is cut off, or 18 is cut off.
Oh, my bad.
So you'll need to send over another
Yeah, I can
picture.
Yeah, I'll send it to you real quick.
Okay.
Alright, so I sent you some more. There was another reply to the one I sent you, so it might be convoluted. But
It's all right. Just make sure I'll make sure I can, as long as I get the picture, I can figure it out. There it
oh,
is.
yeah, I just did the next page where it starts at 20, so it's fine. I can do the other ones later.
Okay, so we'll start at 20, or do you want us to do different ones?
We can do 20. And just
Okay.
there.
Leisure time. The current top scorer on Danielle's favorite arcade game is that number there. Write an inequality expressing all the possible scores Danielle could score to not score lower than her top score. So this is always awkward when there's the word not. So I'm just going to eliminate it for the moment. Write an inequality expressing all the possible scores Danielle could score to score lower than her top score. So here's the number 13,468. So the way it's written, to score lower, it would be everything to the left of it. Okay, but we don't want left. We want the not. So the not changes this to the other direction.
Okay.
But it's much easier to do it without the word not, because we don't use that word when we speak. Like your mom came in and said, hey, we got to leave at, this time. She didn't say, we're not going to leave at a time after.
Yeah.
That would be really weird. And so eliminate that word, write it out, and then the not is going the other direction with the equal to.
Yeah, and then it says
To graph
because
it.
it says lower than her top score, it could be equal or higher.
Yes.
Equal to 13,000 or higher.
Yes.
So it'd be filled in.
Yes.
Okay.
So we've kind of already done a bunch of problems like 21. It says simplify the rational expression 5f to the 9th over 20f to the 4th, if possible. Identify any excluded values. So could you try reducing this for us, since we've done a couple like that already?
Yeah, just give me a sec. Okay. Sorry, I was doing the number. Simplify rational expression f59 over. So we wanna. We can take away 5F to fourth from both of them.
Okay, so what does the numerator become? F to what power?
F to the fifth.
Okay, and on the bottom, what number goes on there?
20F or just 20. Oh.
You're dividing both of them by
Oh,
5,
yeah,
like
yeah. So
just the 4.
4, yeah, sorry, 4.
Now there's no F because all of those F's on the bottom got consumed into the top.
So F to the fifth over 4.
Yeah,
So then,
now the excluded values come from the original. You have to go back to the original, and the bottom cannot equal 0. Okay, so here's what that means. It means that F itself cannot be 0. And the reason is you're not allowed to divide by 0. It's very, very bad in math terms.
so can we do one more like this, like finding an excluded value? Because we went over it in class and I was having a little bit of trouble
So
finding.
let me make it simpler. Let's just say it was something like this. Okay.
Yeah.
You set x minus 1 equal to 0 or not equal to 0. So x cannot be 1. This is the excluded value.
Uh-huh.
So let's look at another one. Let's say it's 4x over 5x minus 10. You set the bottom not equal to 0. And you solve for x.
So it would just like x minus 2 over, or no, 4x over x minus 2.
Well, you don't care about that. You just care about the bottom, just the bottom.
Because you divide both by,
You add 10 to both sides,
oh, okay.
and then you divide by 5. So x cannot be 2.
Okay. So 2x cannot equals 2.
That's the excluded value. Yeah.
Okay, yeah.
All right. Should we stop here?
Let me, yeah.
Okay. I know we didn't get through everything, but that's maybe enough to get you.
No, yeah,
Everything.
it's good. We're good. We're at a good point. So thank you.
All right. Well, this is our regular time. So I will see you